All right, hi everybody. We're going to be starting the lecture now. All right, I'm Never. This is the third time you guys have seen me, or fourth time, and this time I'm teaching like auth with MongoDB. We did most of this last time. My bad. We were supposed to actually do something different, but we're just going to be finishing up the auth stuff. We did most of it last time. I'll just go over it again because it's been a while, and then we'll just finish up the last portion, which was just testing out our code. And that's pretty much it what we're going to do for today. So today's not going to be a super long lecture. I'm going to spend a lot of time reviewing MongoDB concepts so you guys can definitely know it when you guys are working on your projects. So just a quick recap. I taught this all like a while back, but we have like 3 different protocols that we use. We use HTTP protocols, which allow you to communicate with servers on the internet. It just basically allows you to get information that displays that information on your screen. And HTTP requests do all that work for you. They do all that communication. We also have REST, which is an architectural style of building APIs. APIs are application programming interfaces and just allow 2 different applications to talk with each other. So REST is just a way, it's just a standardized way of making those APIs. It's kind of important, I guess. You guys need to know when you guys are using APIs. It's useful to know when you're also building out your APIs. And then finally, the last thing is Postman. Postman is just something we can use to test our APIs. We can send mock HTTP requests and see if it works or not. Yeah, so Postman is just really useful, cleans up all that stuff and makes it very easy to understand if your APIs are working. So definitely recommend using Postman. This is all review. So if you have any questions, let me know, but I'm going to kind of speed through it. Here's like an example of like an HTTP request. You have your computer, you send it to like some API, which communicates with a web server, which communicates with like a database or something. And then you get some response back. So you're sending over a request, getting a response back. That's like the key stuff you kind of need to know from this. What are databases? Databases just help you store data. I know that's like pretty self-explanatory. And you have 2 separate types of like databases. You have SQL databases, like MySQL, Microsoft SQL. So if you guys took CS61A, they teach you SQL. That's like what SQL databases are built on, like that code. And usually data is stored in like Google Sheet style, where you have like multiple rows for every single line of data, like a data frame or something. So that's like how SQL databases kind of work. The other form of databases is NoSQL databases, which is literally just NoSQL. And some examples include like MongoDB, which is the one we're using. And MongoDB is just built on Python. So yeah. So onto MongoDB. The way MongoDB works is you build data structures, like how the data is stored in your database based on these schemas. And schemas are basically blueprints or models for how data is added and stored to your database. So you have like objects in your database. Maybe you have a user object, and within that user object, you have different fields that each user should include. So maybe each user should have a username and password. Those should be 2 fields within the user object or user schema you make. And that's like how the data is being stored in your database. And you define that through building schemas. That's like the foundational aspect of how data is stored in Mongo. And it's pretty easy if you've done object-oriented programming before, pretty simple. But yeah, and there's also CRUD commands, which is create, read, what was it? Update and delete. So we'll go over like the syntax of how to make all 4 of those. These are going to be like the 4 key commands you're going to be needing when you're making your own databases. So I would just like look at the syntax when I'm going over each one of these operations and then making sure you understand them fully. Are there any questions regarding anything I've gone over? Cool. So here's like an example of some schema code. So first what we do is we kind of initialize a schema object. Then we make a new schema object by doing const item equals new schema, which is initializing a new schema object. And within that schema object, we have our 4 kind of categories, which include like the title, task, date, and urgency. And we kind of define what each of these, what's going to be the type of each of these fields. So title is going to be a string, for example. And then finally, the last thing we need to make sure we do is we need to convert this into a model. So MongoDB kind of does that for us, and that'll allow us to kind of use the models we've created to actually store data whenever we're building out the other parts of our application. Any questions on schemas? Cool. Then we have create operations. So when we're doing create operations, basically we're putting new information into the database. So we need to do a post command. So as you can see at the very top, we have a new post command, and that just goes to the /db area. So it's taking information from that /db area. It's getting a request from the user. So remember how I was talking about HTTP requests when you're building out your API? you get an HTTP request, and then you have to give a response back. So right now, they're just kind of taking that request, making a to-do object with elements from the request. So you'll have like the title, task, date, and urgency from the request, and you'll fill out the specific fields in the to-do object. So now you've made this like new to-do object, which is basically the MongoDB schema thing that we made on the previous slide. So as you can see, we made this new to-do object over here. That's that thing at the very bottom. So we made that new to-do object that has these 4 fields. And over here, we're just making a new kind of to-do object. And within that to-do object, we're storing all that information we got from the users. So this is like an example of an application where the user is maybe wanting to create some new tasks that they have to do. And within each task, it has all these 4 elements. And the user fills that out and wants to create that new task. Then your database should do all this work. It should make a new to-do kind of object or task object, and then save it to the database. And that's done over here in this next line where we save the to-do object to the database. This part is creating the to-do object with all its specific information that we get from the request. And this part is taking that to-do object and then saving it into our database. That's done through the .save command, which MongoDB makes for you. And then you do a bunch of error checking in case there are any errors with doing that thing. So in this case, like maybe for some reason it fails, you send an error request just so that the user knows that for some reason it's gone wrong and they should do it again. And then otherwise, you just send a success message. And we went over this like a while back. There are different types of status requests and different types of success messages. It's not super relevant. Just know, like, I believe the important ones are like 200, which means it's perfectly good. 500, which means it's a server-side error, which means your database screwed up somewhere. And 400, which means somehow the client screwed up. So that means the person who was sending the request made a bad request. Those are like the 3 main ones off the top of my head. Those are the ones you should know. And obviously, like in the code we did last week, we already had that kind of planned out. So when I'm going over that code, I'll just kind of re-explain that. But that's pretty much it for like creating new data. Any questions on this? What's up? On security, I'm not at all like somebody who is qualified to talk on that. But in the auth example we had ways of securitizing it through using Salt and other encryption methods. So I'm sure in both SQL and MongoDB-based databases, you have ways of encrypting the data. And they're probably going to be pretty similar because I think most like computer security methods are pretty similar. So to answer your question, 1, you can add security from your side onto your like application. That should pretty much make the security pretty even. And then 2, I'm sure like they're both pretty comparable. Like I don't know for sure though. But from your side, there are definitely steps you can take, which we did in the auth example, that will help securitize your database. Any other questions? That was a great question. What's up?
In the slide before, in the in the to-do thing, what is the string argument?
Which string argument?
The to-do.
To-do. Oh, this bottom one over there.
Yeah.
That just names the object. I mean, it isn't like super relevant. Personally, you can name it whatever, but we tend to name it the exact same as this to-do thing over here. So whatever variable name we have, we tend to make that string name the exact same. And it's just useful when we're exporting the object. But yeah. Any other questions?
Python or JavaScript?
I believe MongoDB is like the database itself, the people who've made it have constructed it in Python. You can use it with JavaScript though. So like on your side, it doesn't matter, right? You can write it with whatever you want. But I think the people who made it wrote it in Python. I'm not 100% sure on that though. Good question. Any other questions? Solid. All right, cool. The next kind of thing we want to go over is read and retrieve. This is basically just getting information. You're not manipulating any information on the database. All you're doing is taking existing information and then displaying it for the user. So for instance, in this application, maybe the user has previously stored to-dos. So they've already made previous tasks they need to finish. This could be like homework assignments or something else. And they want to retrieve that data by maybe pulling up previous tasks. This is an example of how you do that in your database. So you do router.get. And this is like getting all the to-do messages a user has made. And how you do that is you take the schema object in to-do, then you do .find, and find takes arguments. So you can filter through all the to-dos that exist for a certain user, and you can filter the ones that you want to select. This one, if you don't put any arguments in here, it won't filter anything. So it'll just give you back all the to-do objects that exist within the database. And then it'll take those to-do objects and then it'll display all those to-do objects. It'll send a response back with all those to-do objects, and you can take those responses and do something with it. But that's basically what this code is doing, is just taking all the to-dos in the database and sending it over. .find is a method that exists within MongoDB. You can look up the documentation if you want to learn more about how it exactly works. But when you have no parameters in there, then it just returns all the to-do objects or all the objects in the database, basically, based on the specific schema model you use. Any questions on like what I just said? What's up? Yeah, so within like the find command, maybe you put like, so we can go back to, yeah, so maybe we can put like title equals hello or something, or we can put task equals homework assignment 3. I don't know. You can like put specific fields within that to-do object and then make it equivalent to some other like value that you're looking for specifically, and then it'll filter for that value. So you can do stuff like that and get the exact to-do item you're looking for, or a group of to-do items you're looking for.
What if you receive like multiple lines back? Is it looking at the label, you can like put it in index?
I believe it does give you back an array. So like if you have multiple to-do objects, it'll just give you, so if we go back to that previous line of code, as you can see, it's like kind of returning all of these to-dos. So I'm pretty sure it is going to be just like an array of objects that you can get, and then you can take those array of objects, manipulate it, and display it on the screen. Yeah. Any other questions? Cool. The next thing is update. Update is just taking existing information in the database and then changing it to whatever the user wants to be. So the first thing you want to do is make sure that the data that the user is requesting to change actually exists. So we do a .get command. We just make sure that that data exists. We do a little bit of error checking right there, just to make sure it exists. And if it doesn't, we kick them out right there. And if it does, then we continue to the next step, which is a .put command. .put is used to update data specifically. So on the previous slides, we had .get. That's only for getting data. You don't update anything with that. Then you have .post, which is only for creating new data. And finally, you have .put, which is used to update existing data. So then we do .put. We get the ID. We get the item. So that's just like whatever is given in the request. We just take those specific things out. We check to make sure that the ID is in the database. Ignore the database name. This is like some example the previous people made, so don't worry about that too much. We get the specific item by just filtering through the database and then finding the ID. So it's like an array basically. And then once we find it, we just kind of send it back. And if we don't find it, then we send that, okay, there's an error, this object doesn't exist. And that could happen like maybe if, so like one example, this could be like maybe the item itself, like this item that is sent in the request, maybe that item is not associated with that particular ID. And in that case, you can't update that item anymore. So that's just some things to look at. Are there any questions based on this? So you could also just do this in one step. Realistically, you don't really need the .get command. You could just go straight to the .put command, and you could just check if the ID exists within there. And if it doesn't, then you can kick them out there as well. So either way works. But yeah, that's pretty much it. The last thing you can kind of do in a database, the main thing that you guys will be using is a .delete command. And .delete, basically all it does is it just gets rid of an item in the database. So the first step, again, same thing as before. We're just checking to see if an item exists in a database. And if it doesn't, we immediately kick them out because you can't delete an item that doesn't exist in the database. Then we do a .put command. That step isn't entirely necessary, but this step is another way of deleting an item. You can just update the item to be nothing. So that's kind of what they're doing right here. I mean, I would just go with the .delete command. It's simple and it already exists. Like it's pretty much written for you. So like the people who made MongoDB have a bunch of pre-written methods, and this one is just, okay, given the ID, just delete the method for me. And it just does that for you. So that's a great example of abstraction, and it just makes your life a lot easier when you're using MongoDB. Like you don't have to write the delete methods from scratch. Most of them exist in MongoDB. And realistically, I'm pretty sure you probably don't even need the get method. You could probably just go straight to the .delete method and it'll auto check to make sure that that item first exists in the database. And then if it does, then it'll delete it. And if it doesn't, it'll send an error message out for you. This is just lengthening the code out so it makes a little bit more sense to you guys. Are there any questions on deleting items from the database? What's up? Yeah, so we don't need to. We just did this to kind of give you guys a better idea. of different chunks and different steps you need to have when you're checking for items in databases. You don't need the .get method. You can honestly say, I don't want this thought, I don't want these 2 chunks of code, and just jump straight to this line of code. And that'll probably do all the work for you. Yeah, it's just to show you like how to breaking down the code apart, so it's like easier to understand basically.
And if you read everything, just like one mouse.
Yeah. Good question. Any other questions? What's up?
So this is similar to Chamber 6 where we do the .get stuff, and there's more that we just put JavaScript.
Sorry, what was your question again?
Where is it? Where's the MongoDB?
So the MongoDB part, if I understand your question correctly, the way MongoDB is kind of interacting with our code is twofold. The first is through the schema objects. So we have these existing schema objects, these data structure models that we've written out, which is the to-do object, which I introduced a few slides back. And then we have these pre-written methods by MongoDB, which will search through the database that I made in MongoDB, search for those items that I've saved to MongoDB's database that I have, and then find them and delete them if they exist. So that's like the MongoDB code, if that's what you're asking. There is no specific, like there's no MongoDB language. Like there's no language that MongoDB works on. I'm not writing like some MongoDB language. They just have their own methods and I can use them in my like backend code. So as you can see, I've kind of used them in my backend code and I'm just coding in normal JavaScript pretty much. So you can, I'm sure it can interact with most languages. We're just going to use JavaScript in the backend because it's simple and most people do this, but that's pretty much it.
Yeah. Yes.
Cool. Good question. Any other questions? Okay, cool. Now it's just going to move on to the demo. So again, we've already pretty much finished this last time. I'm just going to quickly go over the code again, just so that you guys have a very clear understanding of exactly how MongoDB works. And then we'll do some postman commands. And after that, we'll be pretty much done. I'll just give you guys a secret word after that. And then we can do some homework questions for like 20-ish minutes. But yeah, that's just going to be the general agenda after we're done with this demo. I'm just going to quickly open up the demo on my computer. I believe it is. So if you guys were following along last time, you guys should probably have the code somewhere. We finished almost all of it. I think we finished this last method. So there was like one last thing we had to do. I think we finished that pretty much. At the end of class, we just didn't get a chance to test it. I'm just going to go over everything from the jump again. So the first thing that we did is we just installed a bunch of dependencies into our code. Those dependencies included NodeMon, which is like the kind of NPM start version of like backend code. It just automatically refreshes your page every single time you make a change in the backend. So that was one thing we did. Another thing we kind of did is, that was like the first step. The second step was making this index.js file. So I'm just going to quickly go over this index.js file. I'll just full screen real fast. So the first line of code is Express. Hopefully you guys remember what Express is. Can anybody actually tell me what Express is just so I can know that you guys know it properly? What's up? Yeah.
Just runs the server.
Yeah, pretty much. So Express just helps us set up a server. That was a pretty easy definition. And the way we import stuff in backend code is using the word require. That just helps us import stuff. So that we're importing Express at the very top. Then we're using something called a body parser. That just helps us parse through JSON files and get the information that we need. And then we do this kind of function called initiate Mongo server, which helps us connect to the Mongo server that we've created within our code. So where we do that is in this config folder. And we were writing this out just so that we could make sure we're connected to a MongoDB server so that we can access that information and then save new information to the MongoDB server. So if you go to the very top, the first thing we do is we use this thing called Mongoose. This allows us to connect to MongoDB servers, access information, and save information. So this does all the heavy lifting for us. Mongoose is absolutely necessary. Put it in your config files. The next thing we do is Mongo URI. The Mongo URI is just the area in which your MongoDB server exists. You put that there so that you can connect to the MongoDB server. Hence, that's why we have like that specific weird code there. And I can quickly just show exactly how we did it. So this is one way to have like a local kind of, what do you call it? A local database on your own laptop just for like testing purposes. So that's what we did last time. And as you can see, all I did is I typed mongo sh, which is the Mongo shell script command. And that created this line of code. We have this first part about MongoDB, : all the way up till this part. That is all the information we need from this area. We put that in the Mongo URI, and then we put an extra slash plus the name of the database. So when you guys are building your own MongoDB databases, it'll be on the MongoDB clusters, and it'll be slightly different from this. But this is a good idea and good general idea on how to test out your databases and how to build like a local database, just so that you get familiarity with MongoDB commands. That's what we did last time. And the Mongo URI is just like that first chunk again, plus the name of our database, which is at the very bottom over here, which is just test. So we just put /test there. And then we wrote an entire function just to make sure that we could connect to that specific URI that we listed above, which is where the MongoDB server was. And then if we could, great. We just said connected to database. And if we couldn't, we said console log error, throw like an error, right? At the very bottom. So we're just throwing an error in case there's an error. And we can just quickly test that this works. We can do npx. I believe this was it. Yeah. npx nodemon connected to database. So that works. So now we know for a fact that the initiate MongoDB server kind of works. And you need this function over here just to connect to your database. This just helps you connect to your database. That's it. Any questions on this? So that clusters thing is something you have to set up in your local MongoDB. So you have to like create a MongoDB account. If you go to their website, create a MongoDB account, and you can build like a cluster and then your own personalized database over there. It's slightly different, and it's a little bit like different from what we did over here. But if you can do this part, it's not too difficult to find that part out. There's like docs online that you guys can use, and there's also like a few videos you guys can use. Yeah, let's. Yeah. Yeah, so MongoDB isn't stored in those table-like formats. It's using objects instead. So we have different objects like the to-do object I was showing you. It stores objects in that format versus like a line-by-line format. So it's just a nicer, easier format for people to read. It's based on your preference, really. If you have experience with SQL servers and you prefer them, perfectly fine, go ahead and use them. We're just teaching MongoDB because we view that as easier. Yeah, so clusters is just MongoDB's like special way of categorizing their projects. Once you go to the MongoDB website, it'll make a lot more sense. But they have like clusters, and within each cluster, they have like I think a project, and then within each project, you can make like multiple databases to store any information you might need. And then you can also build schema directly on the MongoDB website instead of doing it in your app. But it's really just up to you, and you'll kind of see it when you log into the website. It'll make a lot more sense. And if you have any questions, obviously drop by in office hours. I'm sure somebody will be able to like walk you through it. Good question though. Any other questions? What's up?
Is there a backend here?
Yeah, this is all my backend code. None of this code is front end. All of it is straight backend. Yeah, so we have like different folders. I think I explained this last time, but we have like a config folder, a middleware folder, models folder, roots folder, and then obviously the index.js file. Normally backends have like a few more extra folders in there with a lot more files, but this is a very basic example, so we didn't want to go super in depth. But like, yeah, this is like the standard things, and I'll go line by line and kind of explain what each folder is doing. Yeah. Any other questions? Cool. Next part is just going to be going back to the index.js file and going line by line to kind of figure out what's going on. The next part is going to be the user thing. So we're getting some information from the roots file. So let's go ahead and go there, and then I'll explain exactly what roots does. So what roots does is on a website, you'll see often that you can go to different areas of the website. So like for instance, on Instagram, when you go to the profile, after you go to the profile, it'll be www.instagram.com/profile. So like the slash and then the part after that constantly changes when you go to different pages on a website. And that's kind of what the roots is handling. When a person goes to different routes on the website, different areas, when you put a slash after the URL on the website, this roots file is going to handle all of that. It's going to first tell what information to send over the user, second, tell what information to get from the user, and then do all that in between stuff, manipulate that information and do exactly what you want it to do. So roots is like handling your heavy lifting on your websites. It's making sure that the correct data is displayed in the correct places, and it handles that through different slashes and different areas on your website. Are there any questions on how roots kind of works and the fundamental idea it's based on? Cool. I'm just going to go line by line then. The first thing we do is we're basically helping users sign up. So when they're signing up for our website, this is like the first chunk of code we do. They'll have to go to the part of our website that has a / sign up after it. And then once they do that, they'll send over some request. And within that request, we'll make sure first that this user already doesn't exist in our database. Because if you already exist in our database, we don't want you signing up again. So we'll make sure their email isn't in the database. We use like a find command, and then we use the filtering thing that somebody asked me about earlier. We just put in the email, make sure that this doesn't return a value. So if this returns a value, it'll probably return like true or something, or it will return the user object that's stored in the database. So we want to make sure that this user object is going to remain null. And then if the user does exist in our database, like if that email is stored in our database with the user, we'll give a status 400, which means a bad request from the user who's trying to sign up on our website, and tell them, hey, this user already exists. Please use a different, please do not sign up with a different user or log in. And then we'll make so if this if statement doesn't trigger, so this if statement, basically, if it does trigger, it kicks us out of this all this code. And if it doesn't trigger, we go to the next line. And in the next line, we just make a new user object. So I know we're using like this user variable over and over again. Don't worry too much about it. This user variable just gets updated. In this case, like if it doesn't trigger the if statement, it's null. So it goes down here and it updates with a new user schema object. We'll discuss the user schema object in a little bit. Don't worry too much about that. But we create basically like a new user with a username, email, and password that we got from the request. Then what we do is we just encrypt the password. So somebody was asking about security. Here's how we do it. We just have a salt. A salt basically adds a random number to your password. So it's harder to decode if hackers somehow gain access to the database. And we use this library called bcrypt, which does all the work for us. It kind of encrypts the password based on some hashing algorithm that it has in the back. And it has like a unique way of hashing different applications. So it's hard for people to kind of figure it out. And we use this random number. I just put 10 in there, right? So this 10 is added onto your password randomly. So then it gets hashed and it gets encrypted. So even if somehow the hackers are able to decrypt your password, there's a random 10 right now that they have to figure out, is that your password or is that not included in your password? So that makes it a lot more confusing for people to get through your password. And then finally, you set the user's password in the database to that password that you just hashed. The reason why you do this is because when the hackers gain access to the database, you want to make sure they have a version of the password that is not the actual password. You want to make sure you actually update the password in the database. And then all you do is this line just saves the user to the database. This is very similar to the save command we saw in the post command on the create slide on the presentation. This just saves. You don't have to do much more than this. We use the await command because sometimes this takes a little bit of time. So we want to make sure we give the program enough time to do it. Otherwise, it might run into some errors. The last thing we do is we create a JSON web token. This allows users to constantly log in without having to constantly put their email and password in over and over again and for us to verify that every single time. Instead, they can just use this existing JSON web token that's stored locally on their device and just send that over to us. And if that's valid, then they just go through instantly. So it saves us a little bit of time and we don't have to worry so much about them doing all that stuff. Yeah, what's up?
Can you explain what that payload is?
Yeah, so the payload is an ID. It uses an ID and it helps encrypt the JSON web token. So that's a lot of words. Let me break that down. First, IDs are stored within a MongoDB database. Every single object has its own unique ID, which is generated by MongoDB. So they'll just do all that for you. We're just taking that ID that we made, we're using the new user object we made all the way up there. We're using an ID that's associated with that object, and we're taking that ID and we're just making a payload with it. This payload is just a new object with only that ID in it. So that's literally all the payload is. It's just something that contains that ID. And then what we do is we make a JSON web token. A JSON web token is what I just described. Within that JSON web token, we use the ID to kind of encrypt it, or we use it as a signature, basically. So we put the payload first. So the JSON web token is composed of a few different parts. The first is like the payload, which is the ID. The second is a random string. I put random string. You can put numbers. You can put like a different string. It doesn't matter. This is just to encrypt the JSON web token so hackers can't get into it. It's just another encryption technique. If you want to learn more about it, you can look it up. We have something about it in our textbook that might go more into depth, but I'm just going to kind of go quickly through it. Then we have an expires in field, which tells us how long this JSON web token is going to last for. If you don't put anything there, I believe it just lasts forever. So you want to maybe have an expiry date just in case. And then we have like error handling at the very bottom, pretty much. But yeah, that's pretty much it for JSON web tokens. Any questions regarding the first chunk on when we're just helping users sign up? Cool. The second chunk is helping users log in. So they already exist within our database and they want to use their email and password to log in. They go to the /login part of our website. So they go to the URL /login, and there they can enter this information. So they send over a request, and that request contains an email and a password, because you don't need your username for some reason, whatever, it doesn't matter. It's not super relevant, but let's just say they're logging in with their email and password. So we get their email and password from the request body. So requests have different parts to them. In this case, we're storing all that in the body. Then we do something very similar to the code up top. It's just slightly different. We just assign a user object. So this is like a variable we've made. Forget about the previous user variables we've had. We just name them the same thing over and over. I know it's a little bit confusing, but just hang with me here. We make a user variable. This has no previous values in this case. And we find a user within the database that has that specific email attached to it. If it exists, it'll send over that user object, which we will assign to that new user variable we just made. If it does not have a user object associated with it, it'll send over something that's a null, and that'll be assigned to this user variable. So it'll either be null or a user object. What's up?
Just to clarify, the user with the capital U, that is referring to the schema object, right?
Yeah.
And so that has a bunch of inherent, I guess, methods that we can use from MongoDB, such as like find one.
Yeah, so we can call MongoDB methods on that user object.
And all that is like imported when you do like import Mongoose.
Mongoose, yeah. So it allows us to communicate with the MongoDB servers that we've made, or MongoDB databases that we've made. What allows us to access or use that specific user schema is this thing up here. Const user equals require models user, and I'll explain exactly what that means. Just after I finish this, I'll go to that. And then I'll explain how that works and how that chunk works. But good question. Any other questions? Cool. Okay, so let's just finish this out then. So if the user does not exist, so if it is basically a null object, this will return true because not null is true, right? And if the user object does exist, then it'll be false. So if it's null, this will return true. This if statement will trigger, your request is bad. So res.status 400 again means that the request is bad. There was an error with the request. You are using a user who does not exist, who does not have it. Your email is not found in the database. There's no user associated with that email. Therefore, you can't be signing in with this email. So it just automatically kicks you out there. And if that user does exist with that email, then it goes to the next part. It makes sure that your passwords are the same. So we're just comparing the passwords. And if it's not a match, then again, you've made a bad request. Please fix your password. And if it is fine, like they match, you go to the next step, which is just sending them a JSON web token. So this is assuming they don't have a JSON web token attached to them. And we do the exact same thing we did in the last chunk of code. We just use a payload, which is the user's ID, attach it to the JSON web token, put a random string in, and then finally send that back over to the user so they can just use that to constantly sign in rather than using their login ID and password. So that's pretty much it. And then I want to quickly go over the models thing. So let's go to this models thing. This is like a schema object sample code we have for a user in our database. So it has a username, email, password created at, and each has a few fields. Each of these sub fields within the user schema object has a few of its own specifications. The username has to be a string, and it is required. The only like different one, I guess, is created at. Created at is like when your account was created. That has a date object in it, which is something that MongoDB has. It's a unique type of data they have. And then you can also set default values using this field. Default is date.now. And that's kind of MongoDB stuff that does that for you. So this is your MongoDB schema. And you can use the schema to kind of access data related to the schema. So if you make a new user object, like maybe some guy named Michael tries creating a new account on this website, it'll be saved under this user kind of tag. And if you want to access information about Michael, who's just made a new account, you use this schema and you use the MongoDB commands that we were showing you in the previous slide, like .find to get Michael. Like maybe you do user, what is it called? So I think you can export this. So over here, we kind of export this as a model. And now we can kind of use that to do all those MongoDB commands. So this is like a prerequisite step. But once we export that and import that into a different file, we can maybe call this like a user schema object, and we can do user schema.find username equals Michael, and that'll get us Michael. So yeah, that's basically kind of the gist of how you do this. What's up?
You define the how the information stored in database here in Canada.
Yeah.
So this is what a schema is. This is what a user is going to do. Passwords. That's all defined here.
Yeah. What's up?
We have all this talk about like MongoDB storing data. Is that stored like on MongoDB's cloud, or like I know you can use the URI and that can get stored in the cloud, but in order to do that, you need to make an account, right?
Yeah.
And then so if it's stored locally, where like exactly is that? Is that within this folder or?
That's a good question. I'm not 100% sure. I think it's probably stored in our cloud because it's not found anywhere locally on my devices. I made a few like usernames and passwords. None of that is stored on my devices. And if you go to the MongoDB website, they have a bunch of different options on how they store your data. And one of them is cloud, the Atlas one, and that's the one I recommend using because it's free for like about like a gigabyte or like 500 megabytes or something like that. So I believe they store all the information on the cloud. It's not stored locally. The database I've created is like a local example, but it's connected to some cloud options, if that kind of makes sense. So this database is not associated with an account. Like if you go to my MongoDB account, you won't see this test database pop up anywhere. Instead, this is just like a local database that MongoDB might create. They might make like a little bit of cloud space for me, and I can just play around with it like a little bit, just to test MongoDB out pretty much.
Thank you.
Yeah, of course. What's up?
There was you can see what's going on with the database.
That's a good question. When you guys are working on your own projects and when you're updating the database, like adding new users or something like that, you'll be able to see it on the MongoDB website. When you start out on MongoDB, it'll give you some sample databases, and that'll give you a better idea of exactly how data is stored. So you'll have like different files, and those different files will be the different schemas. And within each schema, you'll have maybe like one object about like a specific user. So maybe you'll have an object about this guy named Michael, and it'll just be like a few lines. It'll be like username, Michael, email is like michael@gmail.com, et cetera, et cetera, et cetera. And then you'll go to the next user, you'll skip a few lines, and then you'll have those same fields again. That's how information is kind of stored in MongoDB. So locally, I can't see all the users that are stored in my database. But on the MongoDB website, once you connect it to a database on that website, you can then see all your users stored there. Good question, though. Anyone else? Any questions?
This technically is just the blueprint of the MongoDB system.
Yeah, 100%. Yeah. Cool. If there are no questions, I'm just gonna like finish this out. The last thing we kind of did last time is we had this last get command. So when you go to get/me, so the URL of the website /me, you can run a get command. So you'll send a request over, and that request, so the request contains the user ID, and then you try to find the user, and then you send back the user back to the user. So they're requesting information about themselves by just sending an ID, and it'll send them some information back. And the way we're going to do this is we're going to use a JSON web token. And that'll just kind of, so what this will do is it'll just kind of parse that information for that JSON web token, and it'll hopefully work. So I'm just going to quickly demonstrate this last part. So this is just Postman again. We've used this like a few times before. Yeah. So the first thing I want to do is I want to make a new user. And the way I do that is first the URL of the website. So I at the very top of your index.js file, you define what port it's going to be on. And in this case, I made it localhost 4000. That's the port. So you can just set the port to be like 4000 or like 3200, doesn't matter. I think the default is like 4000. So I just set it to the default, which is port 4000. So right now, my node server is operating at port 4000. I want to maybe create a new user. So I can do like sign up. And I think I had to, yeah, so we'll just go with this. And this should give me probably an error because I think I've already done that. Or I think it was a different command, actually.
You have to do user/signup.
You're right, actually, 100%. Yeah, my bad. It's user/signup because in the, and I didn't actually talk about this that much, but in the index.js file, we actually define that at this specific path, so at the /user path, we want to use the router. So the router is all that stuff I was going over, the /signup/login. You first have to do /user, and then you have to put all that information in, and then the router would trigger all of its commands. So good catch, whoever said that. You're absolutely right. You do /user/signup. And I've already made this user in my database, so making it again would just get me an error. So I'm just going to change a few of these fields. And another thing I want you guys to notice is I'm sending a JSON object. I'm not sending like a text. So there are a few options when you're making a Postman thing. You'll have like text, JavaScript, JSON, whatever. Make sure you're using JSON because we're parsing JSON files that are being sent over. So just make sure you're using JSON whenever you're testing out your code. Otherwise, you might get errors that aren't actually like true. So we'll change up the names here. We'll change it to like, so I'm lazy. I'm just going to like flip around the names. It doesn't matter too much right now. Okay, that should not be happening. So maybe there's already a user with this specific email associated with them. So all I have to do is I just have to change some of the words around. So for right now, I don't care that much. So I'm just going to put random stuff. Beautiful. So back, I get a JSON web token. When I was showing you guys on the previous couple of slides, remember I said that if everything goes correctly, you get sent a JSON web token back. So as you can see, we've created a new user. We get this JSON web token back. And I can also test out the login part. But for now, I'm just going to test that .getMe method because we didn't get a chance to test that out last time. And the way we test that out is we just copy paste that information. And we have this like token field. So right now, we're running a .get command. So this is an example of querying in HTTP. So you can get specific information out of a specific URL by using the question mark thing and then setting a specific field equal to whatever string you put in. So that's what we've kind of done over here. Again, like don't worry too much about this. I'm just going to change it because we have a new token. And let's send that information over. And if it works, you should get all this information properly. So we get like an ID, a username, an email, a password to create that field. We get all the details about the user, basically. So by sending over a JSON web token, we've successfully kind of signed in. And you can use this to kind of build out your app using JSON web tokens if you want to. For now, you can also keep it simple by just using usernames and passwords. What's up?
So for a user accessing this website through like a web browser, let's say when we sign in, does the JSON web token automatically get placed in the header, or how does the database know that we contain a JSON web token?
Yeah. So what happens is when you guys, or when you've already signed up or logged in for an app, and when you get that JSON web token back as like a response from the website, what happens is you store that information locally on your device. When that information is stored locally on that device, whenever you send another request, that information is already always included in the headers. Because when you're making an HTTP request, you often include all the details, even if they're not needed in the request. So the request sometimes has a lot more useless information than it actually needs. And so that token is just going to kind of be sent every single time.
Okay, and that's handled by the web browser itself.
Yeah.
As long as we send the token.
Yeah.
Thank you.
Yeah, of course. Any other questions? That was a great question. Yeah, so I mean, that's pretty much it. This is just like an example of how to use Postman. And we worked a lot on the authentication stuff last time. So if there's any confusion about that, I would recommend going back to the videos we did last time. I think it was like 2 weeks ago. It was like just before spring break, maybe a week before, a week or a week and a half before spring break started. I would look over that video if this is confusing at all. And of course, there are tons of like MongoDB videos online. If I'm at all confusing for you, if I'm going too fast, or if like my explanations don't make 100% sense, there are people who've worked on MongoDB for far longer than I've been alive, not alive, but like far longer than I've known about MongoDB. So if you prefer their videos, that's perfectly fine. There are tons of resources you can use. Use whatever resources you want. But yeah, that's pretty much it. If you have any questions, I'm here. You can go ahead and ask me. But that's it for the lecture. And before I forget, secret word, I don't remember the secret word, so let me just pull it up and make sure you guys can get it before you guys leave. The secret word is auth. AUTH. Yeah, and that's it for the lecture. So I'm just gonna like end the Zoom recording, and you guys are free to leave whenever you guys have put in that secret word.